All right, so this first video is going to be about SOHCAHTOA, Pythagorean theorem, and word problems, which were actually the first 3 sections that we did, but since they kind of go together, I'm going to do one video for all 3 sets of notes. Okay, so anytime at all that you want to solve a right triangle, this is what you're going to use. You're going to use SOHCAHTOA, and you're going to use Pythagorean theorem. And I've got the equations right here for SOHCAHTOA. Remember that sine, cosine, and tangent are always of an angle. Those are functions of an angle. Okay? And SOHCAHTOA tells you that sine is the opposite over hypotenuse. Cosine of any angle is the adjacent side divided by the hypotenuse. And tangent of any angle is the opposite side divided by the adjacent side, which is what I've got written down there. And then Pythagorean theorem, a squared plus b squared equals c squared. And c has to be the hypotenuse. Okay, so let's do some problems. Find the exact value of the 6 trig functions of angle theta. So we're using this angle down here. And we actually don't want all 6, we want all 3. So we're just going to do sine, cosine, and tangent. Okay, so to figure out what sine, cosine, and tangent are, we need all 3 sides. We don't have all 3 sides. We're missing a side right here. So to figure out that side, we're going to do Pythagorean theorem. And we're going to plug in the side we know. I'm calling the side we don't know b, and the hypotenuse is 5. So a squared plus b squared equals c squared. So I have 9 plus b squared equals 25. And I'm going to subtract 9 from both sides. And then I'm going to take the square root of both sides. So ordinarily I would get plus or minus 4, but because the side of a triangle can't be negative, I'm only going to choose positive 4. So I can rename this side as positive 4. If at any point during this video I'm going too fast for you, you feel free to pause it and rewind, okay? So sine of theta is the opposite side divided by the hypotenuse. So if we label all these sides, 5 is the hypotenuse because it has to be. It's opposite the right angle. 4 is opposite my angle, so I'm going to call that the opposite side. And 3 is the only side left. It's also next to my angle, so I'm going to call it the adjacent side. So the opposite divided by the hypotenuse would be 4 over 5. The cosine would be the adjacent over the hypotenuse, which is 3 over 5. And tangent is opposite over adjacent, or 4 over 3. Okay? Solving a right triangle means finding every single side and every single angle. Okay, so in this triangle, let's see, we can label these sides. So angle A is across from side A. Angle C is across from side C. Okay, so we do not know side A and we do not know side C, but side B, which is across from angle B, is equal to 2. All right, we have that the right angle, angle C is 90 degrees and angle A is 40, which leaves 50 degrees for angle B because all 3 angles have to add up to 180 degrees. So now I'm going to use this angle down here, which is 50 degrees. And I'm going to find side A. So I have the opposite side, and I want the adjacent side. Okay, so the trig function that uses opposite and adjacent is tangent. So tangent of 50 degrees equals 2 over A, opposite over adjacent. To get A by itself, I'm going to multiply both sides. And then I am going to divide both sides by tangent of 50. And this is where I type this into my handy dandy calculator. And I get 1.678, which I'm going to round up to 1.7. Okay. To find side C, I could do SOHCAHTOA again, or I could do Pythagorean theorem. A squared plus b squared equals c squared. So that gives me 2.816 plus 4 equals c squared. Take the square root of that answer, and I get 2.6. And remember, a good check is that our biggest side should be across from our biggest angle and our smallest side should be across from our smallest angle. Just so that you know, in case you're curious, I could also have used law of sines here because I have a side and an angle across from it, and that is totally fine. Law of sines, as long as you have a side and an angle across from it, you can use law of sines, even if it's a right triangle. Okay? But SOHCAHTOA and Pythagorean theorem can only be used for right triangles like these. So here's another one. This time we have, we have two sides, right? And we only have one angle. So I'm going to use Pythagorean theorem. And I'm going to plug in my side A, my side B. And I get side C is the square root of 13, which I can put in my calculator, and I get 3.6. Okay, so let's just say that I want to find angle B down here. Okay, I have in the picture the opposite side and I have the adjacent side, kind of like what I had just a minute ago. I actually have all three sides now. Okay, so I could use any three trig functions, but I'll use 2 and 3 since those are the whole numbers. Tangent of angle B is opposite over adjacent. So to find angle B, I want the inverse. This is not tangent to the -1, but it is inverse. Okay, so on my calculator I push second tangent of 2/3 and I get 33.7 degrees. Do I have to do SOHCAHTOA again to find angle A? No, I do not, because I know that all three angles have to add up to 180 degrees. So I can use my calculator, subtract from 180, and get angle A is 56.3 degrees. Okay, let's look at some word problems. A surveyor can measure the width of a river by setting a transit at point C, blah de blah de blah de blah. What is the width of the river? B is what we're looking for. Okay, so I have this angle down here is 20 degrees. B, the side that I want, is opposite of that angle, and the side I have is adjacent to that angle. So I'm going to use tangent again, since that is opposite over adjacent. Tangent of 20 degrees would be B divided by 200 meters. To get B by itself, I'm going to I'm going to multiply both sides by 200. And I get B equals 200 times tangent of 20 degrees, which is 72.8 meters wide. Okay? All right, when we're looking for an angle, this one's a little bit different. A straight trail leads from the hotel at an elevation of 8,000 feet to a scenic overlook at an elevation of 11,100 feet. So I'm going to draw this triangle over here a little bit bigger. The length of the trail is 14,100 feet. Okay, what is the grade or the inclination? In other words, what is this angle right here that they're calling angle B? Okay, they tell us that the hotel is already at an elevation of 8,000. The overlook is 11,100, so the difference, or the actual height difference that I'm walking, is 3,100 feet. So to figure out this angle, I decide I have the opposite side and I have the hypotenuse. So the trig function that uses opposite and hypotenuse is sine. So sine of angle B equals 3,100 divided by 14,100. To get angle B by itself, I do inverse. Inverse is always what you use when you are looking for an angle. Okay, so on my calculator, second sine of 3,100 divided by 14,100, which gives me 12.7 degrees. Okay? All right, so let's look at some angle of elevation and angle of depression. These can be really tricky, especially angle of depression. What you have to remember is an angle of elevation is always from a line of sight or a horizontal and a line that goes up, like if you are looking up into the sky. An angle of depression is if you are looking down at something. Okay, it is the angle that is right here between a horizontal and a line that goes down. Now the triangle that you're actually trying to solve might be down here, okay? So you might have to draw your angle outside of the triangle, which is okay, all right? It's going to be the same as the angle down here by the object because those are, excuse me, alternate interior angles, okay? Just have to be really careful with that. So let's look at an elevation and a depression word problem. Excuse me, meteorologists find the height of a cloud using an instrument called a ceilometer, okay? The angle of elevation from the light detector to the base of the cloud is 75 degrees. What is the height of the cloud cover? Okay, so this right here is an angle of elevation because it's from a horizontal and a line that looks upward. Okay, so if we look over here at our triangle, I want to find the height of the cloud ceiling, which is the opposite side. I have the base of my triangle, which is the adjacent side. So I'm going to use tangent. Tangent of 75 degrees equals opposite over adjacent. I'm going to fill in those two sides of the triangle. To get h by itself, I'm going to multiply both sides by 300. And then I'm going to type that into my calculator. And I get 1,119.6 feet. Okay? I think angle of elevation, I think, is a little bit easier. I hope that one makes sense. Let's look at an angle of depression, and this has a picture, which is nice. From the top of a fire tower, a forest ranger sees his partner on the ground at an angle of depression of 40 degrees. So see, the triangle that we're trying to solve is down here, and our angle is outside the triangle. Okay, if the tower is 45 feet in height, how far is the partner from the base of the tower to the nearest tenth? So, because this angle up here is 40 degrees, this angle, which is alternate interior, is also 40 degrees. Okay, so looking at our picture, I have the opposite side. I want to find the adjacent side. Opposite and adjacent means I'm going to use tangent. So tangent of 40 degrees equals 45 over x. When x is in the denominator, you have to be really, really careful, don't you? I'm going to multiply both sides by x. And then I'm going to divide both sides by tangent of 40. So that I can get x by itself. So I have 45 divided by tangent of 40, which gives me 53.6 feet. I hope that makes sense. If you still have questions about either SOHCAHTOA, Pythagorean theorem, or word problems, I would recommend that you rewatch this video, take a look at the review homework, and if you would like, ask one of your classmates that taught one of those 3 lessons. Okay? Be sure you guys study. Good luck on your test.